Alright, lesson 1.2, solving two-step equations. So before we had one step where you just only need to do something, you only need to do one step, either just addition, just subtraction, multiplication, division, and then you're done. You found your answer. Now, two-step equations or multi-step equations. We have, let's say something like this. 4x plus 1 equals 5. What does this mean? Well, we have multiple things happening. If you remember, our goal, solve for the variable. Figure out, okay, what side is the variable on? It's on this side. And what's happening to it? We have multiple things here. We have one, it's being multiplied by 4. And another one is being added to 1. So there's two things here. Which one do we do first? Two different ways of thinking about it. We have one way is just, this is a little bit more intuitive of you deal with whatever is furthest away from the variable or whatever you're trying to solve for. What is the furthest away here? The furthest away here is the plus 1. So you do that one first. The second one, a little bit more straightforward. If you remember, PEMDAS, the order of operations. We've got, as a reminder, P stands for parentheses, E stands for exponent, M multiplication, D division, A addition, and S subtraction. PEMDAS, you use that, but you go backwards. You PEMDAS but backwards. As a reminder, addition and subtraction is kind of on the same level, except you go left to right if you have multiple of the same thing. And multiplication division are also on the same level. So, PEMDAS but backwards, you do addition or subtraction first. You do the minus 1 first. So, I'll rewrite this here. Most of the time I'll be referencing opposite of PEMDAS because furthest away from the variable is not that... It's more intuitive than having a solid rule. So I'm going to be referencing the solid rule first of reverse PEMDAS. Addition or subtraction first. So we take care of the plus 1 first. If you remember, inverse operations. Opposite operations, things you can do to get rid of the other thing. Addition and subtraction and multiplication and division, crazy. The inverse operations are also grouped together. So addition, subtraction first. Subtract both sides of the equal sign to keep things equal, if you remember. So those cancel out. Now we have 4x equals 4. Is there any more addition and subtraction to do? No. So now we move on to multiplication and division. There's multiplication happening here, the 4 times x. So now we take care of that next. Remember, how do we, inverse operation of multiplication, opposite of multiplication is division. Because we have 1 on the top, 1 on the bottom, those cancel out. 4 divided by 4, anything divided by itself is 1. And if we want to, check it by plugging it back in. 4 times 1 plus 1 equals 5. 4 times 1, 4. 1 plus 1, or 4 plus 1, 5. Whoops. Come on. That's correct. If anything, just here I use the order of operations. PEMDAS, you did stuff in the parentheses first. Technically there's a 1 in the parentheses, but there's nothing else that's happening there. There's no exponents. There's multiplication happening of the 4 times the 1, so I did that first. Anything else? No. Any division? No. Addition next. I did the addition of 4 plus 1, so order of operations. If we did it the other way around, things might get... The answer would be different. Like, for example, if we did the plus 1 instead of just like, okay, 4 times 1 plus 1. If we did the plus 1 instead, it'd be 4 times 2. 1 plus 1 equals 2, equals 5. 4 times 2 is 8. Are those equal? No. So that's why order of operations is important. And that's basically the gist of it. As long as you remember, PEMDAS reversed, and then you just follow that to try to figure out, isolate the variable. I'm going to run through some more examples real fast. 6x minus 3 equals 9. Figure out, okay, what's happening here? What side is the variable we're solving for on? This side. What else is here? Multiplication and subtraction. Reverse PEMDAS. Addition and subtraction first. So deal with the addition subtraction first. Dealing with subtraction. So we add to both sides. Those cancel out. 6x equals 12. And your addition and subtraction? No. So now we move on to multiplication and division. 6x, same thing as 6 times x. Opposite multiplication, division. Those cancel out. X equals 2. Next one, 3 plus 2m equals 15. Here, because we have a number with no sign on it, I'm going to put a little plus sign in front. It's a positive number. Just pretend. Maybe not pretend. It is. It's positive. Or, like I said, you can use commutative property. You can swap them. 2m plus 3 equals 15 is the same exact thing. You can see it's plus 3, so you subtract 3 both sides. Those cancel. 2m equals 12. Now there's multiplication left. Whoops. So you divide both sides. M equals 6. Another example. Let's do 5 minus 3h equals 8. Invisible positive. So I'm subtracting 5 from both sides. Addition and subtraction first. Negative 3h equals 3. Negative 3h, same thing as negative 3 times h. Divide both sides by negative 3. 3 divided by 3 is 1. We have a positive divided by a negative, which is negative. H equals negative 1. I'll move on in a second. A couple more example ones just to run through those real quick. At any time, you can just pause, try to do it on your own, and then once you're done doing it on your own, check it with what I have. Addition, subtraction first. Subtracting 1 from both sides. Those cancel. 2a equals negative minus something, same thing as negative, plus a negative. So 1 plus 11, 12. They're both negative. Slap a negative sign on it. Divide by 2. 12 divided by 2 is 6. Negative divided by a positive. Since the signs are different, the answer is a negative. Negative 4, not plus, minus 2n equals negative 24. We have a negative 4. Opposite of a negative is a positive, so you plus 4. Those cancel. Negative 2n is equal to negative 24 plus 4. A negative plus a positive. You subtract them. Bigger number takes the sign. 24 minus 4, 20. Which one is bigger? 24. Negative or positive? It's negative, so negative 20. Negative 2 times n, negative 2n. So divide to get rid of that multiplication. Those cancel. 20 divided by 2 is 10. Because they're both the same sign in division, negatives, both are negative, so the answer is positive, so n equals 10. Some extras if you want to try to do some practice on your own right now. 2 minus 5v equals 42. 10 minus negative 4, or 10 equals negative 4 minus 2x. And 4 minus 5n equals negative 36. Try those on your own. I'm not going to show you the work, but I'm going to give you the answers and just see if you got the right answer. Here, v equals negative 8. Here, x equals negative 7. And here, n equals 8. So I'm not going to show you the work. Try to do it yourself. Now, another topic alongside this is something called combining like terms. What does that mean? That means, let's say you have something like this. 2x plus 4x equals 24. What you do here is you just add the 2x and the 4x like they're the same, because they are like terms. Like terms are just, let's see, things that share the same variable relationships. So in this case, there's 2 times x and 4 times x. They are like terms. 2x and 4x are like terms. If you had 2x and 4xy, those are not like terms, because this one has a y and this one doesn't. They both have to have the same exact variables. Now they're like terms, but these ones are not. So, if there are like terms, let's rewrite this right here. Just add them like normal and just slap the same thing on it. Treat the variables like a name tag. If you have the same name tag, you can combine them together, be the same person. So 6x equals 24. And from here you can solve for x like normal, right? 6x is the same thing as 6 times x. Divide both sides by 6. X equals 4. Let's try another one. Negative 12 equals 9x minus 6x plus 15. What I like to do, you can use different colors. If you have fancy highlighters you like using, you can just use different shapes, whatever. I'm going to box. I'm going to use the same like color, same shape as the ones that are like terms. If I do it, then you'll understand. Box 9x, box minus 6x, or negative 6x. Circle plus 15, circle negative 12. So the ones that are in pink, the ones that are circled, are like terms. The ones that are in blue, the ones that are boxed, are also like terms. I would recommend making sure you keep the operation that's to the left of it as part of it, because if you combine like terms, it can be the same thing as 9x plus negative 6x. You combine like terms on the same side, by the way. 9x plus negative 6x, or just 9x minus 6x. That's just 3x. 9 minus 6 is 3. So once those are combined, that's 3x. Carry the other things down. And now you can solve like normal on the two-step equations. We have a multiply by 3, and we have a plus 15. Reverse PEMDAS. Add or subtract first. So we subtract 15 from both sides. Because these are like terms, you might notice the 15 and the 12 are like terms. That's why we can combine them like this. This is the same thing as combining like terms. So those cancel. 3x is equal to negative minus negative plus negative. Negative 12 plus 15 is 27. Any more just subtraction? No, there's just multiplication. So now we divide, those cancel, x equals, we have a negative divided by a positive, so the answer is negative. 27 divided by 3 is 9, so x equals negative 9. Now we try another example. Run through this real quick. Negative 2x minus 10x plus 12 equals 24. I'm going to do the same thing. I'm going to box the like terms, circle the next ones. We're going to do the same with underlines even. You can do one underline for these, 2 underlines for those ones instead. That also works. But we combine like terms like usual. Negative 2 plus negative 10, or negative 2 minus 10. Negative 12x plus 12 equals 24. Same thing with two-step equations. Addition, subtraction first. Subtracting 12 from both sides. Those cancel. Negative 12 equals 24 minus 12 is 12. Now there's only multiplication. So we divide by negative 12. 12 divided by 12 is 1. There's a positive divided by a negative, so it's negative 1. And that's it. Let's try a trickier one. 3q minus 6 is equal to 4q plus 8. Figure out our like terms. Boxing the q's. Circling what doesn't have a q. So, now this is a little bit tricky. If I draw a line down, because our goal is to just isolate a variable, right? But now our variable is on both sides. So what do? One thing, the main thing, always to remember, in this case, it's q equals something or something equals q. Doesn't matter which side it's on, so just pick a side. I know, no matter what, we're going to have to subtract to go from one side to the other, or to just remove it from one side, because both of these are positive. This is a positive 4q, this is a positive 3q, so we're going to have to subtract, because it's just like normal and combining like terms. If we're subtracting the numbers. If I do minus 4 on both sides, 3 minus 4 is negative 1, so I'm going to have a negative q. I want to try to avoid dealing with negatives. So I'm going to do the other way around. I'm going to subtract 3q from this side, from both sides. So this gets canceled. Negative 6 is equal to 4 minus 3q is 1q plus 8. Oops, and I'll just highlight this instead, actually. And 1q is the same thing as 1 times q, right? Which is the same thing as q. So we can just write q. Negative 6 is equal to q plus 8. And then you got it from here, right? Subtract 8, subtract 8. Those cancel. Negative minus, which is a negative plus a negative, which the answer is negative. And then 8 plus 6 is 14. So q equals negative 14. So in the end, you just pick a side for it to be on. I chose it to be on the right side because I knew putting it on the left side would have me as a negative q. Let's see what happens if you do that. Just to run through it real quick. 3q minus 6 equals 4q plus 8. Minus 4q, minus 4q. Those cancel. Now we have a negative q, or negative 1q, same exact thing. Minus 6 equals 8. Technically, the plus 8 can carry down too, but it's the same thing as adding a plus in front of every number that doesn't have a sign. So, add 6 to both sides to get rid of that 6. Now we have a negative q equals 14, but we want a positive q. If you remember, negative q is the same thing as 1 times q is a negative 1 times q. We just want q. How do we get rid of that negative 1? We divide both sides by negative 1. 1 on top, 1 on bottom. Those cancel. Q equals 14 over 1 is 14. 14 is a positive. 1 is a negative. Positive divided by a negative. The signs are different, so it's negative 14. So q equals negative 14. Some more extras to do on your own if you want some practice. 8y plus 3y equals 44. Solve for y. 6c minus 8 minus 2c equals negative 16. Solve for c. This one I'll actually go through. 36 equals 13n minus 4n. And h plus 7 equals negative 8 minus 2h. I'll write down the answers for these ones. Y equals 4, n equals 4, and h equals negative 5. But this one I'll go through. The c one. So I'll just run through this real quick. We've got 6c, that's one like term with negative 2c. Negative 8 is a like term with negative 16, but those don't get combined because they're not on the same side of the equals. The c's get combined though, same exact way. If you want to, you don't have to. You can rewrite it so that they're next to each other, if that makes it easier for you. But you don't have to do that. You can just see as well. We have a 6 minus a 2c, or a 6 plus a negative 2, which is negative, not negative, 4c, 6 minus 2, minus 8, negative 16, and then you got it from here. Add addition, or subtraction first. 4c is equal to negative 8, divided by 4, both sides, c is equal to negative 2. So, let's see. Now next, last topic, multi-step, but with distributive property and some more stuff on top of that instead. So we're going to bump it up a little bit. Let's say we have 2 parentheses, v minus 5 is equal to 10. If you remember what the distributive property is, basically, when you have a number, variable, unknown thing, that's what variables are used for, number on the outside of a parentheses, and something is happening inside the parentheses, doesn't matter. 2 different terms. Because as we see here, we have a v and we have a 5. Those are not like terms, right? So whenever they are 2 different terms, then you distribute. You distribute the outside to the inside with multiplication. Because this is the same thing as x times the entire parentheses, right? It's another invisible multiplication. So, let's do the first one. X times a plus, carry that down, x times b. So we have xa plus xb. Mathematical convention, if you have multiple variables multiplied by each other, you put them in alphabetical order. So technically this should be ax plus bx. And you can do the other way around as well, but right now we're focusing on just distributing. So, going back to over here now, distribute the outside to the inside. 2 different terms. 2 times v minus, carry that down, 2 times 5, go to 10. 2 times v is 2v, 2 times 5 is 10, equals 10, and then it's the same thing like usual. Plus 10, plus 10, addition, subtraction first. Those cancel. 2v is equal to 20. No more addition, subtraction. Now it's multiplication, division. Another way to think about this, not involving the distributive property. This is only if the outside number that you would be distributing can go evenly into what the entire equation is equal to. Because, if you remember what I just said, having the number on the outside of the parentheses is the same thing as multiplication. How do you want to do multiplication? You divide. So you can divide the whole thing by 2. You have 1 on the top, 1 on the bottom. It's separated by multiplication, so those just cancel. Now you have v minus 5 equal to 10 divided by 2, 5. And we can get rid of the parentheses because now there's nothing outside of the parentheses to be happening here. So we can just get rid of them and solve for v. Plus 5, cancel, v equals 10. I will recommend you distribute first. That's the safer way of doing things. Because this, like I said, it's only if you notice that whatever can go on the outside, if you divide it, then it will go evenly. Because sometimes it might not. What if this was 11 instead? It'd be 11 divided by 2, now you have to deal with fractions and stuff. So, just distributing is the safer option here. Might take a few more steps, but you have to notice things first. Let's try another example. Negative 3, parentheses, 5 minus g equals 3. Distribute. negative 3 times 5. Carry down the minus. Negative 3 times g equals 3. So now we have negative 15 minus negative 3g equals 3. I will also tell you, whenever you're subtracting a negative, they can cancel out, and you can just be adding instead. So they go positive. So negative 15 plus 3g equals 3. You could also think about it from here when you were distributing. You have the negative 3 times the 5, and then you have negative 3 times negative g. Well, there's like a plus in there maybe. Equals 3. Negative 15 plus negative times a negative is a positive. 3g equals 3. So it's the same thing. It's whether or not you want to think about it like this subtraction is a negative g, or this subtraction is just a subtraction. Up to you. Either way, the result is the same, so long as you remember that subtracting a negative equals, they cancel each other out to just be plus. So normal two-step stuff from here. Add 15 both sides. Those cancel. 3g is equal to 18. No more addition, subtraction. Now multiplication, division. 1 on top, 1 on bottom. 3's cancel out. G is equal to 6. Another example to bump it up a little bit. 3. Well, I guess I could. Like I said before, with this whole thing, you could have noticed, hey, negative 3 goes into 3 evenly. It's just negative 1. So you could have, whoops. So you could have done divide the entire thing by negative 3 if you really wanted to. 5 minus g equals negative 1. Minus 5, minus 5, those cancel. Negative g equals negative 6. Divide by negative 1. G equals 6. Could have if you wanted to. But like I said, safer method is just distribute. Now with a slightly harder example. I don't know why I wrote 3. It's supposed to be 2. Parentheses 1 minus x plus 3 equals negative 9. Now if I remind you. PEMDAS. Reverse PEMDAS. Addition, subtraction on the same. Multiplication, division on the same. Even though we're solving for x, you can distribute first if you want to. We can distribute this too. 2 times 1 is 2. Minus 2 times x. 2x. Carry down that plus 3 equals negative 9. And then we have some like terms here, a 3 and a 2. You can do, doesn't matter which side it's on. 2 plus 3, 5, minus 2x equals negative 9. And then normal two-step stuff. Addition, subtraction first. Minus 5, negative 2x. Negative 9 minus 5, negative plus a negative is a negative. 9 plus 5 is 14. Divide both sides by negative 2. X equals positive 7. Or, could do this in a different order. You can just subtract 3 straight from here. Because from here, there's still addition subtraction that we can do. We can subtract 3 from both sides. Just get rid of it over here to only have the distribution. Negative 12. And then from here, it's the same ordeal. You might notice 2 goes into negative 12 evenly. Or you can distribute like what we did over here. We have distribute like we did over here. Subtract 2 from both sides. Divide by negative 2 on both sides. Or dividing both sides by 2. Subtract 1, subtract 1. Those cancel. Negative x is equal to negative 7. Divide both sides by negative 1. X equals 7. always end up getting the same exact answers. It's just a matter of which way you want to do it. I'll run through... Actually, I don't think I will. I'll write down some more practice problems for you to do on your own if you want to. I'll give you the answers if you want to check yourself. 3x plus 1 plus 6 equals negative 9. We have 13 equals negative 2. Y minus 4 plus 3y. Ooh. We have some even slightly harder ones. 5 parentheses 3 minus x plus 2 parentheses 3 minus x equals 14. And then 2x parentheses 5 minus 3 minus 3x equals 5. Some slightly harder ones. This one, x is equal to negative 6, so if you want to check yourself. This one, y is equal to 5, if you want to check yourself. This one is a little bit harder, but I will still tell you, it's still the same thing, distribute, and then go from there. X is equal to 1. And this one is still harder, but still just remember, you're distributing the entire 2x to these. It's going to be 2x times 5 minus 2x times 3. And don't forget that minus 3x. And you go from there. This one, x equals 5. So I believe that is it. Yep. That's all those. See if you can do those on your own. As usual, if you have any questions, leave a comment on this video or just email me if you have it, or the next time I see you in class if you're one of my students. So don't forget main things for two-step equations. To solve for them, we have multiple things happening. Remember, reverse PEMDAS. What is happening? What can you do first? Addition, subtraction first, and then multiplication, division. Remember about the inverse operations on how you get rid of things. These are called two-step because they take 2 steps. One step was the addition, subtraction. The other step was multiplication, division. 2 steps. And don't forget about combining like terms. Like terms are things that share the same variable relationships. These are like terms because they share the same multiplied by x. These are not the same because that one's 2 times x, that one's 4 times x times y. Just like normal, like numbers themselves, they're not multiplied by any variable. So those are like terms. Whenever you do 8 plus 6, that is combining like terms technically. So just remember, thinking of variables like a name tag, especially since soon there can be multiple variables, especially multiplied by each other. So those are the main things: combining like terms and reverse PEMDAS to solve two-step equations. See ya.